Clinker Factor, the cement industry podcast.
Welcome to the Clinker Factor, a podcast from WCA, which looks at the cement industry's response to climate change around the world and other topics of interest. I'm Ian Riley, CEO of WCA, and your host on the Clinker Factor. So at WCA, we've just completed a review of the top plants in our benchmarking and performance improvement project, which we call Pegasus 2020. And we looked at the top 5 plants for clinker power consumption, for cement power consumption, for heat consumption, for CO2, both in clinker and cement. And every one of the top 5 plants in each of those categories used advanced process control, and in most cases, we're using some AI. So I think AI is a very topical subject, and one that offers a lot of potential for the cement industry. So I'm delighted today to be talking to Liran Akavia, who is the co-founder and COO of Seebo. And Liran, welcome. Perhaps we can start by asking you to introduce yourself and explain how you got involved in the cement industry.
So hello, Ian. Thank you very much. I'm happy to be your guest in your podcast. So as you mentioned, my name is Liran Akavia. I'm one of the co-founders and the COO of Seebo. And my path to the cement industry started from the computer science world. At Seebo, we are very much excited from merging the virtual and physical worlds together. It's always been my passion. My previous venture was around that before it was acquired, and also Seebo is around this world. And in kind of an early part of my career, I understood that combining the virtual ability and the breakthrough we see in the recent world of analyzing big amounts of data, combining that with the physical world of manufacturing could drive a lot of value. And those were the seeds. And the results is here today, where Seebo, the company that I co-founded together with my brother, we help the largest manufacturers around the world in different sub-verticals like steel and cement and glass and food and chemicals. We help them to optimize their production lines using artificial intelligence.
Okay, so is this combination of the physical and the digital, is this something similar to a digital twin, or is that a different concept?
So the industry is pretty big, and there are many different companies that are doing different things. Digital twin is a term that is used a lot, and I would be surprised if everyone agree on what it is. But usually digital twin is a reflection of a physical asset in the virtual world. And Seebo is actually not doing that. Seebo is doing something that is slightly different. At Seebo, we are interested in the process and not only in the asset. I could have each one of my assets, the kiln, the cyclone, the cement mill or the raw mill, I could have each one of them working very well. But I would get good results on my plant with throughput, quality, cost per ton, emission, only if all the assets work well together. It's like having an orchestra, having a very good violin player and a very good guitarist. They could be very good, each one of them independently. But if you want to hear really the good music, you need to orchestrate them together. And this is exactly what Seebo does. We are interested in the process. We built algorithms that are understanding the process, and this is the I would say, new thing that we bring to the table.
Okay, so could you, as a sort of background, give us a little bit of a picture of the different kinds of AI that are used today, and then how what you do fits into that?
Certainly. So let's zoom out for a moment, not speaking even only about manufacturing. AI can do many different things in medical diagnosis, in marketing, in manufacturing, obviously, in autonomous cars, and so on. With artificial intelligence, you can ask a computer to understand an image or read text, or understand movement, or understand manufacturing process. Some people see artificial intelligence as kind of a magic wand or a black magic. The thing is that there are many types of artificial intelligence, and there is no one card that fits them all. I think it's obvious that you will not take the artificial intelligence for image recognition or autonomous cars or medical diagnosis and put it in manufacturing. But then even if you zoom into manufacturing, even in the world of manufacturing, there are different types of manufacturing. There is batch manufacturing, there is discrete manufacturing, and there is continuous manufacturing, which the cement industry is part of. And then even if you take the cement or clinker manufacturing, you need different types of AI. And I'll give you two examples. One that would look on an asset and will ask if the asset is going to fail. It's called predictive maintenance. And the other one is the one that will look at the process and will ask, is the process efficient? And that would be predictive quality and yield. So even when you zoom in from the very top to the very bottom, you understand that there are different needs, and every need has the algorithm that fits. And the general statement or the general recommendation from our point of view is do not deploy AI for the sake of deploying AI. Make sure that you look at your business and ask yourself, what is my business need? And only then look for the right technology.
Well, I think that's very good advice, whether we're talking about AI or almost anything else. So people do often do projects because they're interested in the projects and lose sight of the business objectives. So I think that's a good general advice. So if we turn to Seebo in particular, can you explain what is special about what you do in terms of the way that you apply AI to the process optimization?
Certainly. Before I explain Seebo, I would like to speak about the challenge. Once we all understand the challenge, it will be easy to understand what Seebo does. So let's look at most of the cement manufacturers, if not all of them in the world, and let's look at their process. In terms of KPI, I have many KPIs. I would like to increase throughput. I would like to reduce cost per ton. I would like to increase alternative fuel rate. I would like to keep emission low. I would like to have energetical efficiency, and I would like to increase the refractory lifetime by running the kiln in the most efficient way. So here we go. We have 5 different KPIs. One of the challenges of those different KPIs, 5 or 7 or 10 or 9, it doesn't matter, is that each one of them is not a standalone KPI. They are actually pulling the same short variables, and they are all looking on the same resources. For example, I could really optimize the quality in a plant, but I would need to sacrifice the energy and the throughput. And I could, with just a simple decision, I could increase the throughput on the account of quality. Now, the deep question that we really ask, can we increase throughput, increase quality, reduce cost per ton, reduce energy consumption, and keep emission low altogether? So there is this master KPI. There is this KPI that actually take into consideration not individual KPI, but the global operation of the plant. And this is the KPI that the manufacturers are looking to improve. So from one hand, we have many KPIs that are sometimes contradicting each other. From the other hand, we have many process parameters. We have actually thousands of process parameters that are affecting dozens of KPIs. And if you connect to that we are humans after all, our brain, as smart as we are going to be, is limited. We cannot digest thousands of parameters against dozens of KPIs and decide at every given moment where the process should be and what are the optimal process parameters. So if we take that as a challenge, this is where process-based artificial intelligence kicks in. In order to optimize process using data, anyone that would like to do it will need to master 2 disciplines. One discipline is the artificial intelligence and machine learning, and the other discipline is the clinker and cement knowledge, physics and chemistry. The act of embedding this knowledge, the cement and clinker making knowledge, into an algorithm is an ultra complex task. There are many cement plants in the world, but none of them is identical to the other. You need actually to learn the specific kiln, learn the specific plant, take into consideration the specific raw materials and the weather around it. So embedding this knowledge is a huge challenge into the algorithm. And this is exactly the challenge that Seebo took. We built algorithms that actually learn and understand specific manufacturing process.
Okay, so you're not applying a standard tool. You're applying a methodology that first of all looks at the specifics of the plant and presumably the specifics of the KPI objectives as well. Is that right?
Yes. So actually, we have a solution that we developed. So far, invested around $46 million in the developing of this solution, software solution. And the software solution is able to take the needs, the businesses of the plant from one hand, and create this master goal, the goal that optimizes all the KPIs. From the other hand, the algorithm is able to learn the manufacturing process and come back to the manufacturer and explain what are the process parameters that the manufacturer need to employ or deploy in order to run in the most efficient way.
So would that include advice on, for example, additional sensors or additional information that is necessary to optimize it, or is that something that you're taking whatever information is available?
So unfortunately, there is no short answer here, and I would like to explain. Most cement manufacturers has a lot of data, and usually within this data there are low-hanging fruits, and this is where we recommend to start. Let's use the data that you have. Let's monetize it as much as we can, and later, if you want to go a step further, you can deploy more sensors. But from the other hand, we would speak with the cement manufacturer. We would ask the cement manufacturer what is the most painful point for now, and let's say that that would be a clinker uniformity or something like that. And the cement manufacturer is unable to measure it efficiently. They would have to deploy the relevant technology. It could be a lab, it could be an inline measurement, and so on. But generally, if I would sum it up in a simple way, most of the manufacturers has plenty of data that it's possible to monetize.
Okay, so when you are starting out on a project, what are the biggest challenges that you would typically face working with cement producers?
So I would not call it straightforward challenges, but I would say what are the steps that we are going through, and it's not always easy. So the first step is the definition of the business goal. It's a surprising fact. It's not a straightforward answer from a manufacturer. What is it that you would like to improve? Other than I would like to improve everything. What are the most important parameters right now? And also, what is more important for you right now? Is it the throughput or the cost per ton or the quality? And so it's a work that we do with the plant.
And of course, that can change even seasonally, can't it? So in the high season, it might be more important to get every last ton. In the low season, it might be more important to optimize for cost. So I guess in some plants, they can even have seasonality of objectives.
Yeah, we see that quite often. And one of the things that we see quite boldly is that the executives will better understand that, while the team in the plant is not always seeing to that. And this is another goal that we took to connect those points to enable the I would say the management decisions to be very visible to the team on the plant. So the first thing that we do, it takes time, is to define together with the team in the plant their business goal and see the business goal in a live stream of data, something that we can track at any given moment. The second stage would be the data connectivity. This is usually not a big deal, but this is a logistic step that needs to be done. And the third thing that sometimes we see as challenging is the change management and the team. When the right team is working with us, it's amazing. It flies forward. We have strong cooperation from the plant. The algorithms coming with a recommendation. See the teams deploying their recommendations, and the value, the savings are clear.
So what characterizes those more efficient and less efficient teams? Is it just whether or not they've embraced change before, or is there something else that you find? You know, the teams that you're able to work with very efficiently, do they have some common characteristics that you've noticed?
So in short, yes, we built a methodology around that. If I would start to work today with a manufacturer, I would ask them to find a team that is excited about having new technology on board. and excited about making something new. Some people, this is their passion. One of our clients told me a few weeks ago that using the Seebo solution, they actually attract more talented people now because the people are excited about it. So I would usually prefer to work with this kind of team in the beginning. When working with this kind of team, we have a success, and then we create an internal success story. Mm. And once you have the internal success story, the other teams are starting to ask to be part of it. And this is how we spread the excitement around the organization.
Yeah, no, I think I've seen that same methodology applied in many other types of change initiatives, and I think it works extremely well. So you've got the team, and what's the next stage?
So assuming that we have a live data connectivity and that we have a well-defined problem, we let the algorithm run and analyze the data. The algorithm will actually look at the target against the process data, the alternative fuel data, the raw material data, the weather around the plant. So those are all parameters that affect the goal. And the algorithm will come back to the team with what we call an operational envelope. The algorithm will say, look, guys, let's take those 20 variables. Let's make sure that they are between X and Y range. And as long as you stay within this range, you are going to run more efficiently. Usually in the first go, it's not 100% accurate. So we have some back and forth with the process expert to make it more accurate. The process expert will use tools for the Seebo solution, such as automated root cause analysis, event analysis, and the envelope optimizer. And once we identify the envelope, we execute that to production. The solution, the Seebo solution, will help the team to make sure that they are operating within the required envelope, using different alerts and mechanisms to stay within the envelope.
And so as the project progresses, explain a little bit how it goes. So you start that out and you identify some quick wins. How does the project sort of mature, and what's the end point?
So Seebo is part of a continuous optimization greater goal. The plant is not stable forever. Mm-hmm. And I would say from the other angle, the goals are not stable forever. As you mentioned, seasonality could affect the goals. So we will work continuously with the plant to optimize. So they would see the envelope. We would make sure that they're running within the envelope. We will see the KPIs going towards the right direction. And then something happens. Maybe alternative fuel delivery has changed. Maybe raw material is coming from slightly different place. Maybe management decided that they now prefer throughput on cost, and that would shift a little bit. It would change the reality, and then the algorithm will run again. Will generate a new envelope. We would make sure that we are running in a new envelope. It goes like that on and on and on and on. And even plants that are pretty optimized and running pretty well, we can always tighten the envelope and try to get even better results. Honestly, I never saw a plant that would say, okay, guys, we are good to go. It's all perfect, and we don't need it anymore.
So can I just make sure I've understood that correctly? The application of the algorithm is to set up an envelope of process control parameters, not to actually execute the process control. Is that correct?
Yes, that's correct. Seebo is not an expert system. Some teams are using the knowledge they extract from Seebo to program the expert system.
Yes, I understand. Okay, so it works sort of hand in hand with advanced control systems or expert systems, and works out the best parameters to set up those systems. Is that the right way to understand it?
That's correct.
Yeah. Okay. Great. So in your experience then, what do you think producers can expect to gain from applying this kind of system? What kind of gains do they see in, I mean, perhaps one that's very topical at the moment in the week of IPCC publishing its latest report, what might they expect to see in terms of fuel efficiency or CO2 footprint?
So yes, we hear it quite often. The use case that we hear the most in the last, I would say, year is my goal in the plant is to increase the alternative fuel rate in order to reduce costs and reduce emission. But alternative fuel rate is very difficult for the process. It makes my life difficult with throughput and with quality. And I want you guys from Seebo to help me to increase alternative fuel rate while maintaining quality, maintaining throughput or increasing throughput, and make sure that I cross this journey safe.
Do you have case studies that you share? I think on your website I've seen some case studies that talk about some of the improvements that you've achieved.
Yes, certainly on the website there are case studies. I think that one of the case studies speaks about a manufacturer that wanted to optimize the kiln stability through kiln amps, and you can see the journey and the results from that.
That sounds good. So if a cement company was interested in working with you, where would they start? I mean, what would be the first step other than picking up the phone? But I mean, what in practice, what would they need to do to prepare?
To identify the business needs. That's from one hand sounds really simple. From the other hand, it's not obvious for everyone, and it's not something that you do within one meeting. So simply sit down within the company and decide what is important for us, what exactly are our priorities, and are we willing to push throughput on the account of quality or cost, or maybe cost now is the most important thing. What is the let's say cost is the most important thing. How low can we go with throughput? Are we willing to give up 1,000 tons a year or only 50 tons a year? So all those questions you must ask yourself, because at the end of the day, the algorithm would need those constraints in order to optimize to the right place.
Okay, well, thank you for that. That was a very clear explanation of how AI can help cement companies to figure out how to optimize, and indeed what they're really trying to optimize. So Liran, thank you very much for speaking to me today.
Yeah, and I always enjoy speaking with you. This is it's a real pleasure. Thank you very much for the time.